Hi guys, today we will learn about how to calculate the diagonals in a polygon. It's easy to draw the polygon and find the diagonals in case of easy figures like a square or a pentagon. But imagine finding the diagonals of an octagon or a dodecahedron. So drawing the polygon itself is time consuming, and then counting the diagonals is out of the question when you have a race against time. So, let's start with easy figures and then conclude on a simple shortcut to find diagonals in an n-sided polygon. First of all, what is a diagonal? A diagonal is a segment from one vertex to the opposite vertex, which is not part of the main polygon. Secondly, for any n-sided polygon, each vertex should have n-1 segments to other vertices. Out of n-1, 2 will be part of the polygon, and the remaining n-3 will be the diagonals. In this example of a quadrilateral, n is equal to 4. Thus, each vertex should have 3 segments, 2 being the part of the quadrilateral and 1 being the diagonal. As from vertex 1, vertex 1 to vertex 2 is the part of the quadrilateral. Vertex 1 to vertex 4 is also part of the quadrilateral. Vertex 1 to vertex 3 is a diagonal, which is not part of the total quadrilateral. Vertex 1 has one diagonal shown in red. Vertex 2 has one diagonal shown in green. Vertexes 3 and 4 have no new diagonals as they are already accounted. Thus, the total diagonals are 2 in a quadrilateral. Here, in a pentagon, the vertices are equal to 5, so each vertex should have 4 connections. 2 will be part of the pentagon, and 2 will be diagonals. As you can see, there are 2 red diagonals from vertex 1. Similarly, there are 2 green diagonals from vertex 2, and then vertex 3 has 1 purple and already accounted red diagonal. Thus, vertex 4 and vertex 5 have no new diagonals which are not accounted. Thus, the total diagonals in a pentagon are 5. Here, in a hexagon, the vertices are equal to 6. Thus, each vertex should have 5 connections. 2 will be part of the hexagon and 3 will be diagonals. As you can see, there are 3 red diagonals from vertex 1 and 3 green diagonals from vertex 2. Vertex 3 then has 2 purple and 1 already accounted red diagonal. Vertex 4 has 1 blue and 1 already accounted red and green, and 2 already accounted red and green diagonals. Vertex 5 and vertex 6 have no new diagonals which are not accounted. Thus, there are a total of 9 diagonals in a hexagon. Here you can see a pattern that the first 2 vertices have the same number of diagonals, and later vertices have reducing number of diagonals like 3, 3, 2, 1, 0. Here in another quick example for a heptagon, vertex 1 and vertex 2 have 4 diagonals and then a sequence of reducing diagonals of 3, 2, 1, and 0 follow it. Thus, the entire sequence is 4, 4, 3, 2, 1, 0. In total, the diagonals number is 14. Thus, for an n-sided polygon, the first and second vertices have n-3 diagonals, then it is reducing until the number 0. Thus, it sums to a shortcut formula as n times n-3 by 2. Thus, you can easily estimate the diagonals for a 100gon, which could be a nightmare if you need to draw it and count the diagonals. done, make sure to hit the subscribe button and click the notification bell so you can stay updated. See you soon!